Okay, I'm assuming everybody can see my screen.
Yeah, it's visible. Just before you start, Anish, I just wanted to give one quick background overall. So originally, for those people who don't know, Bahmni has been written in Angular JS since 2012, which was the hot new thing at that point in time. And over the time, Angular itself moved from Angular 1 to 2 to now Angular 15, 16 and above. And we haven't been able to keep up with the change. And also, OpenMRS started an initiative of rewriting their front end in React with micro-frontends a few years back, which uses React with Carbon. And the idea was that we wanted to see what are the harmonization options across OpenMRS and Bahmni. We realized in last year's pilot that it wasn't going to be as easy to integrate the OpenMRS components into Bahmni because the underlying foundation is different of the front end in OpenMRS written for OpenMRS and in Bahmni, which is primarily Angular based. So we've been trying various experiments to figure out what are the options where there are certain harmonizations possible. And also because we want to move away from Angular and write everything in React micro frontend, since Angular 1 or the one that we are using is no longer a supported framework. From our perspective, Bahmni's perspective, I guess there are three scenarios at a high level that will occur. One scenario is where we are building a brand new, front-end app that is, like a patient portal in current, which is a separate app, doesn't actually sit with Bahmni, but speaks to the backend, which could be built, independent of any of the overheads. The second situation is where we are building a front end which acts as a sub app, which can be hosted on its own proxy on its own container, but just linked in Bahmni, and that could potentially follow its own tech stack because it's independent. And the third case, which is the most complicated, which is where the IPD team that Anish is part of and others, where you are building certain screens and widgets which are in React and micro frontend, but they need to coexist in some of the Angular screens. That's the part that will, if it is executed well, it will allow us to have a smoother migration strategy where all new work happens in React, and we slowly, as we build capability and understanding, we start migrating the Angular stuff over to React. And this journey has to some degree already started. The teams have started building, sub apps. Like we've got the appointment sub app, the Lab Light sub app, which is like all React running inside Bahmni. But I think the IPD team has this third scenario, which is more deeply integrated or coexisting of Angular with React. So that's some ultra super high level sort of overview. And I think today the idea is for Anish and the IPD team to speak a little bit about, what IPD team is going to do for this coexistence, and also to provide some guidance for, other people who are doing development on Bahmni on how they need to potentially think about things, given that we have some, historical framework choices to also consider in this context so that people don't get confused with all the new tech and old tech all together in the same Git repos. Yeah, that's it from my side. Thanks. Anish, over to you.
All right, awesome. Actually, thanks, Gurpreet. You put the context really nicely, so I don't have to go through that. Like Gurpreet mentioned, we've been working on a micro front-end strategy with Angular and React. And we basically have the MVP of that, like the first initial cut. Things are working fine. And so in this call, I'll basically explain the architecture of that, how we went about doing that, and what are some of the technical decisions and trade-offs that we did to achieve this, and potentially what would be the future evolution of this, right? So I'll get straight into it. I'm assuming we all know the tech stack of Bahmni, AngularJS, and we know the problems associated with trying to integrate React with AngularJS. So we have basically gone through, so I'm creating the documentation at this point, so this is just a draft of that. So when Gurpreet has talked about the problem, So I will go into what we did to solve this. So essentially, for Bahmni, we are using Webpack's module federation plugin, which allows us to run React code at runtime from a remote server, right? So module federation basically allows a JavaScript file from being served from a different container or web server, which has React code, and to be loaded at runtime in another application, right? What this, how this allows Bahmni to work is that the React code from the separate served instance is actually owned by a different team. So we'll get into all of that and how that works out. So I have a pretty basic architecture diagram of how we have set things up. Just for quick context, how this diagram will work is there are parts of this diagram which are React. So all the React parts are all blue. All the Angular parts are all orange and yellows, shades of that. There are some containers, folders, all that stuff, right? So I'll go overall how we achieved this. So this is our main Bahmni apps. Let me just lock this so that the toolbar doesn't come in. Yeah, okay. So this is our main Bahmni apps AngularJS multi-application repository, right? So right now the fundamental issue was that to include any kind of module federation plugin and the Webpack setup, right? We needed a Webpack build, but the existing build, of course, as you know, is grunt based, right? So mixing those two together is kind of tricky. So what we ended up doing was there's a top level new folder. So all of this is in a branch for IPD, our main branch. So we have a top level new folder called Microfrontends, where we will be housing all React code, future React code, which is to be built and then to be integrated with all the Angular apps that we have, right? So we basically have a dual build system that we've enabled into Bahmni apps. Of course, we've added onto the pipelines to get these things, orchestrated. All of that is done. But essentially, we have a separate build for Microfrontend, right? Which is very React-based sphere. Cool. So within that, we basically have three big components, and I'll go one by one from the simplest to the most complicated and how things are working out. This is a Webpack-based build with multiple entry points, which basically means that for every entry point, it's going to build output another build file. So to get things from the micro-frontends into the Angular world, we basically went through a build process which outputs all of this build files, right, from all the sources within the micro-frontend, and puts it actually within the visibility of your Angular app. So within the UI app, there's a new dist folder for micro-frontends. We just called it micro-frontends dist. It's git node. And this is accessible to all your Angular apps. So your typical, they can load them as they are loading any other JS file, right, in their index HTMLs, right? So this basically allows, this basic flow allows your Angular apps visibility into the built JS files, right? So this is how we did. This is like a parallel dist folder, not even parallel, this like outside of micro-frontends, but this works. Okay, so there is so to get things working, we basically have a couple of standard dist files. One is a shared dist, which basically contains some polyfills for things to work, because as I'll show you soon, there's a bit of polyfilling and there's a bit of Angular adapter code involved. So there is, the shared has got some polyfills, common styles, all of that. So first things first, we have a local micro-frontend, right? So let's say we need to create some React components to be injected into Bahmni apps, Angular applications, but we don't need to house them in a separate repository. Maybe they are very shared, common UI components, right? Controls that we want to build in React, and maybe we want to migrate to them sooner or later, right? So we basically have a new local micro front end. For lack of a better name, I called it Next UI in terms of next generation UI. Naming we'll figure out later on. But essentially what is happening here is that we are using, so these are the React components. And at the end of the day, the React component is wrapped over with an Angular adapter, right? So your React component is wrapped with adapter, which is coming from a library called React to Angular. It wraps over a React component and creates an Angular component out of it. So this is for every React component that you want to inject into your Angular application, we basically build one Angular adapter component. Of course, what this means is a bit of boilerplate. There's a bit of repetitive code involved, but for first cut, we felt this was a decent strategy. And for all of this, basically wraps inside an Angular module, right? So this module is called bahmni.mfe.nextui. So any Angular application here, for example, clinical, right? So if it needs this this component, this blue component, to be injected into its Angular application, in the init.js of it, they basically mark bahmni.mfe.nextui as a dependency and make sure that shared.min.js is included in their HTML before their init runs, and things just work out fine, right? So you have an adapter component for this. I'll not go into too much of the code, how this works out or what it looks like, but this is overall how things work for a basic React component. And outside of this adapter, everything is basically React, like your standard React. All the build systems are integrated. You have your tests, you have your it has its own ESLint, all of that stuff is there, right? So this is the basic glue. You have a adapter component using React to Angular, and all of that is integrated into a single Angular module, which can be required by your applications, right? I'll talk a bit more about how data can flow inside and outside of these components, but mostly this is the overall strategy in local micro frontend. I'll just take a pause. Any questions on this one?
Would you show the working example of this after you finish all, or will you do one after the other? If you could like show an example of this working on a screen, that would be helpful. Or
I have an example of a proper remote micro frontend. For this, I think we nuked out the example, but that also just works the same. I'll show the example.
Okay. Thanks.
All right. Cool. So that is Next UI. As of now, it's a single entry point. I did not feel the need for multiple libraries like this, but if community feels that there are more libraries that can come into this, of course, this shares the same disadvantage that this library is built alongside Bahmni apps, right? So any additions to this is basically means that you're rebuilding Bahmni apps, right? So the more interesting use case, of course, is that what if we want to have React components sitting on a different repository altogether, right? And that being independently deployed and then reflecting automatically into the front end of Bahmni, right, based on that team's deployment cycle, right? So for that, we have the idea of what I'm calling a remote micro frontend, right? So this remote micro frontend essentially works with the module federation plugin of Webpack, which allows dynamic loading of JavaScript files, which have React components, and that basically works out with a React component. So how it works is, actually, I'll go from right to left on this one. So module federation basically has two parts. One is your host. So the left-hand side, this would be categorized as a host. And the right-hand side, where we have React components lying around in a different repository, is your micro frontend, or I forgot what the official term is, right? So in this micro frontend, we basically have one micro frontend right now. We are calling it OpenMRS module IPD frontend for the IPD dashboard and components. So with module federation, what happens is you have there's the concept of entries, right? So you can expose certain top level React components as entry points into your module, right? So for now, this is an example where we have drop chart and add to chart button as two entry points, right? So you can imagine the drug chart as being the inpatient drug chart, like their schedules and all. And add to chart would be like a button that exists in different pages where the caregiver can, click on it and open up a modal to add that medication to the drug chart, right? So these are two different components that at the end of the day in Bahmni UI are rendered at different places, right? But essentially they are part of the same feature for IPD. So these are your top level entries in IPD frontend. And through your Webpack configuration of module frontends, Webpack's module federation, we can configure these to be your top level entry points. There's of course a whole configuration how to do this. And what happens is after the build process, your web server is basically serving something, a file called remote entry.js. Now this is just a conventional file name for this. People always call it remote entry.js, and that's also what we're going to say. This is basically a pure JS file which exposes these components, and this file in turn uses other partials and static assets, right? And this is a simple Apache web server. Currently, we've set it up inside the Docker Compose as a container, and this is being proxied. So all of that classic setup can be done. So once you have this remote entry, the idea is that on the Angular side of things, how this works, again, we have the same setup of creating a fresh Angular module. So this one is called bahmni.mfe.ipd. And this module has, again, Angular adapted components, right? So it has a component 1 and component 2. More interestingly, this has a local React component, right? So I don't know what to call this component. You're calling it a ref component, refcomp2. This has a local React component. This component is very isolated. It just sits inside this repository. And this component has just got one job, which is to use, so we use React suspense model. I can quickly show the code for this. But we essentially use a suspense model of React and lazy imports. So React allows us to lazily load a component, right? So when this Angular component is loaded into the UI at any point, that time it does a fetch call and gets the remote entry and runs this component live, right? So this component is not bundled along with this setup, right? The drug chart is always going to be fetched at runtime using lazy loading mechanisms and all of that, right? So that is why we have this ref component, and the core adapter remains the same. Your Angular module remains the same. Everything else, same strategy. And this goes through the build process, and you have a separate JS and CSS file for this. We'll talk about the CSS a bit more later. But essentially, if you include this JS file in any, for example, patient is including this, and they require this Angular module, they get access to this component. And whenever they render this component, the local React component runs. And whenever the local React component runs, it picks up a live version of this component, whatever is being served, right? If there is nothing being served, it goes into an error. So it's not a build thing, it's a more runtime thing, right? So this is how the overall structure of a remote micro frontend is. Again, I'll take a pause. Any questions on this? I'll show an example for this and probably show a bit of code. But this is overall how the flow works. Any questions on this till now?
So in this world, you're saying the React code is in a separate repo, which is its own repo. And the build process, in a way, publishes it so that it can be served through its own web server. And it is wrapped in this remote entry.js to allow that serving in a way to happen. And on the consumer side, you have this, you have some mechanism so that you can use a ref component, which is just referencing these entities. That ref component is also wrapped in that same bridge code, Angular React bridge code. And then at runtime, when this is loaded, it makes a load call to the assets to be served and the component to be served. So you always get at runtime the latest components which are actually hosted completely independently, and your build process only has a reference to them, which means you don't need
Correct.
to rebuild. Correct, no?
Correct. So we essentially never need to rebuild this micro front end code unless, let's say, you add a new component and you need to reference that, right?
Right.
Um,
Right.
and as of now, it's going to pick up the latest remote entry, and the only way to control that is through browser level caching. But in future, if we want to reversion it or something like that, there are mechanisms to do that in the configuration here, bit more involved. But essentially, it picks up the latest remote entry, whatever is being served, and it will render those components. All right. So that is the overall architecture of this. Now, through this bridge, we basically have the ability to pass in data from the host and pass it to the React component through standard props of React, and also pass in callbacks from the host so that the React component can call those callbacks and your host can react to them, right? So for example, you can pass in your patient information and stuff like that into the component. The React component can render those, and more interestingly, you can pass in callbacks. The host can pass in, let's say, on close callback. So whenever, let's assume this was a modal, right? So whenever the modal is confirmed or like canceled or whatever, right? So they can just call that function and the host can react to that and remove this component from the DOM. So all of that is possible. There is basically a convention to do that. It's a convention I wrote, but essentially there's a convention for that. I call it host data and host API. Probably not get too much into that, but that level of feature is there. I'll quickly show an example for this anyway. I just reload this. Okay, so till now this has all been Angular, right? So this is your Angular code base. So within the Angular code base, through configuration, we have enabled this dashboard drug chart. So when I click on it, I'm not sure if you can see this clearly, but just open it up on the right hand side. A remote entry was then fetched, right? And this is basically React code. And this section that you see over here, this is an active development. It doesn't look like anything, but this is part of your drug chart that our developers have been building. This section right here is basically in a different repository. It's being served from a different container. This is a React code, right? And this basically runs the rest of the whole page is Angular. Right? And we just fetch that remote entry and we pass in some information to their patient information, all of that. And this renders it out, right? So that's basically how this works. At this moment, we removed all the dummy examples, which were around clicking on things here and then getting things out, reacting to that. But this is how it works. This remote entry, if you look at, we've basically proxied the remote entry to, there's a reverse proxy rule that we've added for IPD. This is coming in from a different container altogether, right? And let me see if I can quickly. And the other beauty about module federation. Yeah. So this you see is localhost 8080. This is basically the same component being rendered in a sandboxed environment, right? So what module federation allows us to do is that this remote entry, right? It's not specifically just for this. We can actually reuse this for other React-based applications or itself, right? You can have your own sandboxed environment which loads this and loads your components in a development environment. Of course, any data that you want to pass through the host, you need to mock it when you load it in a sandboxed version. But we have basically set that up so that the developers can develop on their own and then integrate it at a later point, right? So overall, the core advantage here is that developers working on this part do not need to consider any Angular at all, right? The build is clean. There is no Angular dependencies. So if you know the appointments module, for example, is a separate Angular app with its own React thing. It needed to have a lot of static build-time Angular dependencies. None of that here. This is all just React. All of the Angular-based bridge code is residing on the Bahmni apps, the main front end, and that does all of that work. And once it is done, you don't need to touch it again. Cool. That's about it, the core architecture. Side note, one other thing that we've been doing is for the Carbon design system, we have created a wrapper library that we are, this is not really part of the whole micro-frontend stuff, but it is core to it. So we are using the Carbon design system and wrapping on top of that, we have some shared components that we have put into a new library called Bahmni Carbon UI. Both of these are published to of course, Carbon is anyway in NPM. We are also publishing Carbon UI to NPM. Right now, this is in super beta stage. We are basically figuring out what are the common components which can be shared across micro-frontends. So right now, this is a separate library. Tomorrow, we may think maybe it doesn't need to be, or it could be another micro-frontend. It could evolve in a lot of ways. But as of now, these are very not very kind of dumb components, which do not have a lot of business logic, but are repeated UI elements that we have put in here. And the setup has been done so that the micro-frontends can access this, and the local micro-frontend can also access this. And the Carbon design is a common dependency across all things, right? So all of that setup is done. That's the overall architecture. And before I show any code, there are certain tech decisions that I wanted to talk about with this architecture. So this documentation would soon be available. Okay, so one of the some of the decisions and trade-offs that we did with this, just want to quickly go over that. Node and React versions had to be locked at 14 and 16 respectively. This is like the upper version of the ranges that Bahmni anyway supported, but below 14, the Webpack features needed for model federation does not work. So we had to lock that at 14. We'll see if this becomes a big problem, but 14 anyway is quite an old Node version. We should be moving on. In any case, we locked in at 14, and React at version 16 for similar reasons. There was some existing usage of React at static build time that was using this, so we did not want to break it. So we used React 16. Also, so the reason for lock-in is essentially it's a bit finicky with model federation. If the versions don't match, or if there are other issues, especially with hooks around, they tend to break easily. So this had to be locked in. Because of Node, Carbon components is also locked in at a slightly older version. The impact here is that the Carbon design system has moved on in its CSS strategy. It's a bit different now. So the developers, when they look up the documentation for Carbon latest, it looks slightly different in terms of how you'd style it, but should be straightforward to find the old documentation and get the right style. And it maps. There is no new features as such. It's just the strategy is different. So this is a small point of contention. We are running with old Carbon, but yeah, that's because of the whole Node version problem. We'll probably revisit this and see if this actually updates with 14. To keep things simple for developers, and since you're also using Carbon, we have not introduced any new kind of styling solution. Like there was, of course, temptation to use CSS and JS and all of that. We are still going to support Sass. So there is provision in all of this setup that Sass files which are built into separate style sheets for each individual micro frontend gets flowed in. That's why you have the min.css files separately. Like all of these contain their own, come with their own style sheets, right? So ipd.min.css contains the style sheet for IPD, which are just pure SAS files which have been built out. So that provision is there. There is an added provision for module SAS, which is CSS modules. So there is some CSS and JS support that we are slowly migrating to. This does not need that min.css, but kind of does. But yeah, so that much support is there, but we did not go all out with a different styling solution anyway. The other thing is configurations, right? So the micro frontends do not have a innate concept of configurations as of now. They are of course free to call the configurations on their own. It's a standard React stuff, or else you can pass in the configurations as pure data from the host application, right? During runtime. But they don't have a core concept of configurations. We did not feel it super necessary for the first cut. That's why we've not added it as of now. But of course, the host can control how they show up and all of that. Right? There are some minor things like the React, for technical reasons, is relying on window.react because there was old code that was relying on that, and it's not being bundled. The impact here is that the Webpack configurations is a bit more involved than what you would see standard in module federation. Especially the micro front-end side, the Webpack configuration is split out into two for local and sandbox separately. But otherwise, the actual source code looks like every other React code. So tomorrow, when we finally move to React at some point and we have a more traditional React bundling strategy, all that is needed is to simplify the Webpack configuration, and things will just work out. No major code changes are required, right? But this is something that has to be added, and I will be documenting this a bit more why this was needed and the kind of hacks that were required to solve this. But yeah, that's one thing. And just want to quickly show how your Angular component passes on data. So there is this concept of host data that any wrapped, so this is a wrapped, this is an Angular wrapped micro front-end component, and you pass in host data, and that component can, pick that up and render it. At the end of the day, through a couple of steps, the component gets it through props. They can do something simple like this and then start working. There is also the host, the host reacting to events from the micro frontend. We have not set up a full-fledged event framework for now because it felt overkill for the MVP, but that is something that in future we can think about. So it's pretty straightforward. In objects, you can pass in functions, and that is passed in as conventionally called host API. And at the end of the day, through the props, they can essentially call those functions. There's a bit of issue here around React to Angular not recognizing things at the first click. There is a bit of JS workaround that needs to be done, but it's pretty straightforward. And when you click this button, the host gets to close the modal or do whatever it needs to, right? So all of that works out pretty straightforward. That's overall the capability right now. We can pass in data and we can react to events from these components. Bare bones set of capabilities we'll probably build on top of this depending on need. So yeah, that's pretty much it in terms of overall architecture. Any questions till now on this? Oh, and one thing I probably missed, translations. As you know, translations is a big part. So each remote micro frontend right now handles their own translations. We could potentially look at sharing code translations from MFEs, right? Your Bahmni host can potentially pass on translations, but we've not built up abstraction for that. Now, the local micro frontend, that next UI gets the translations from Bahmni frontend as it is. There are abstractions for that. So that has been solved, but that's how translations are currently. So any questions till now? Okay, so I won't show a lot of code, just show some of the more important bits, just so that we have a rough idea of what's happening. So this is the whole micro-frontend build folder that I was talking about. Here is how your Angular bridge code looks like. You create a module, and this module is being used by init. So this module is being required by clinical init, and through like loading the right files, it gets through this, and essentially some wrapper components are created. Here we've done 2 levels of components because one is getting the controller and passing in some extra stuff. But essentially this is pretty, there are recipes for this that I'll add to the README, how these are built. But essentially in clinical dashboard, right? So you can basically run your micro-frontend like any other Angular component and pass in data that is required, right? So all of that is possible. And so this is like so this is the local ref component that I was talking about. This is the IPD dashboard, which is being right now not used. Let's look at the drug chart model, right? So this is the drug chart model that's being wrapped into a React to Angular wrapper. And this is like the ref component. So this is where the magic happens. We have some suspense and lazy imports from React. This basically allows us to import this. This path is set up in your Webpack config. Basically, this at the end of the day maps to that web server serving the remote entry.js, and that is this path. And inside remote entry, we've exposed a couple of components. One of them is drug chart. So this dynamic import, when this runs, this is not an import at top level, it's a dynamic import. This is your lazy app. So we use suspense and lazy to get this. This is what actually does that magic of loading a remote React component at runtime. We have a standardized prop structure for host data and host API. This is just a convention that I came up with. We might change this, or people might change this later on. But essentially, we are passing in some props, data, like drug order, scheduled frequency, start time, and we are passing in a callback, right? So close drug chart, like how to close that, and that's how this works. I don't think I have the setup to run this correctly, but this is a very copy pastable ref comp. All ref components will look something like this, except for what goes inside the host data. Everything else is pretty much the same. There may be some CSS things that you can do here, but not a lot of code should be here. Ideally, most of it would be inside the lazy app, which would be the runtime drug chart model. Right? So that would be in a different repository. Right? So chart model, I have it here. This is that remote component from a different repository that picks up that host data and host API. All your entry components are, there is a repository structure for this. I'm hoping to create a template for this in GitHub so that a new micro-frontend can be quickly scaffolded out, right? So this picks up that host API and then runs with it, right? All of the rest is React. So that's how overall it works, and overall the architecture is. Yeah, that's all that I wanted to show today. Cool. Any questions on this? No.
Yeah, I think that reference repo for people to use as a starter for writing their remote micro frontend, I think that would be definitely very helpful if it could just say this is what it is, and then I guess the rest of the documentation is on the wiki on how to consume it.
Yeah, so that's something that I'm actively working on right now. We'll, depending on how you want to prefer, we can create either a reference repository or we can create a, I think GitHub has templates for repositories, right? So one of those tools, we can set it up and I'll add a lot more documentation within the code in READMEs and plus the wiki. Wiki I'm currently building some more rough edges. It is published right now, so you can potentially go through this, just a starting phase. It is under the developers guide, architectural and technical documentation. There is micro-frontend architecture for UI. So this has that same diagram. And it has a bit more info, still figuring out where to place all of this, but it is in some amount of starting state for now.
Yeah, no, this is pretty helpful as long as it has the repo links for people to refer, and you can just like put, like, for instance, if you're looking at build, you can say this is an example of the build file and this is why it is done like this and so on. So you can directly put references to the specific code blocks. So I think that's usually helpful to understand the context. And then I'm guessing the GitHub actions have the build process in it. If you could just show one of the GitHub actions, the fact that it first builds the micro front end and then it is consumed somewhere else, that would be helpful.
So GitHub actions anyway are separate for both the remote repository and the local, but I can, I can show. You can. So Bahmni apps. So the GitHub actions have been updated. In the micro-frontends folder, we basically do a yarn install, test, and then build. And what this does is it creates the that yarn build basically creates the dist folder in app micro-frontends dist, right? So this is what it ends up doing. This is git ignored, of course. This is your micro-frontend for IPD, right? And all that needs to be done is before running the grunt. So this is your index of clinical. There is specific spots where you can include the CSS and JS. So I've included the shared CSS and I've included the IPD CSS. Actually, this is empty right now, but nevertheless. And below you see we've included React. So this is your window level React and React dependencies. And after that, you have shared min.js. This is again shared code from the micro frontends, right? And IPD min and then next UI min, right? So IPD is your IPD micro frontend, and next UI is basically your local React micro frontend, right? So just doing this and then getting the dependency in your init.js gets hold of that components. So of course, for this, that build has to be run first. So that's how the CI is set up. The CI process for the micro frontend itself is pretty straightforward. I think there's a build. If I look at repositories. So it just does a yarn build and all that. And then it puts it in Docker. The thing here is that we've basically run it in a container and we've proxied the IPD to that. Where can I show that correctly? So this is the remote repository. So here in the dist, there is a separate dist for federation for various reasons. This federation folder, essentially this contains the ITN and this contains a remote entry. This basically is put into an Apache container and served as it is, right? And that container is then, what do you call, referenced by the Webpack Module Federation. If I go into Webpack Module Federation configuration, it will get too much, but I can give a quick glance. There's a lot of things going on around here, but there's a bunch of things going on around here, but essentially we are using IPD as a subpath at the core because we have a proxy there and picking up the remote entry from there. I will not get into this. There's a lot of things here. We'll probably document this by so many and so much is here. But this basically allows us to have a dynamic, whatever is your window, wherever Bahmni is deployed, on the proxy of that IPD proxy, the remote entry.js is picked up, and that is in that's set up in Docker essentially. Right? So yeah, that's a very quick run through of the connections there. But again, getting into that is getting too much into weeds, so I would rather not do that.
No, this is helpful. Thanks. Another related question was around your components repo. You mentioned there is a components repo which has the bare bone basic components that are being used by the remote or the apps. That repo is it completely free of Angular stuff? It's just like a normal React component list. Can anyone use that? Those components?
Anyone can use that. This is in active development right now. We are still figuring out what the best strategy for this is. Expect a lot of changes. But yeah, this is a pure React component repo, which publishes to NPM at in the pipeline, right? So any merges to the main will publish this to NPM. This is being used to share code between multiple micro-frontends in terms of pure React components. So this you can use start immediately. For example, if you have a React application which is completely separate, like the one you were talking about, where it's a separate application altogether, even they can use Bahmni Carbon UI, right? Of course, Gurpreet, one of the things would be like you'll have to set up a governance model for this, how to contribute to this, and all of that. What goes inside here right now? It's a slight bit of Wild West here, but once this is a bit more stable, then it should be taken forward nicely.
Right, and a related thing to this is Storybook, right?
Storybook, as of now, is there on Bahmni Carbon UI. It overall has nothing to do with micro-frontends. For example, this repository has got Storybook set up, I believe. So if you run the Storybook, it runs these components. This one needed Storybook. The micro-frontends themselves, it's basically a team's call if it needs a Storybook or not. Most likely, it could be a overkill if you anyway have a sandbox environment.
Okay. My last question was around so you said the common components can be reused by anyone, but any of the micro front-end components, can they be used in a non-Angular app, or will they only work with Bahmni for now because of all the wrapping that has been done now? So the IPD control you made, right? The drug chart control, can it be used, let's say, in a non-Bahmni world?
Yes, absolutely. Right. So so this component, right, as long as you do not add a lot of business logic in the ref component here, because this ref component is in Bahmni, right? Bahmni app. Any other React frontend, if they set up their, they also have to set up their module federation plugin correctly. They can actually access this and just render the React components directly, right? Same lazy suspense model. A lot of documentation on the web how to do this. Pretty straightforward. So this essentially can be reused by other React applications. The code of drug chart actually is not even aware that it's in a module federation kind of a setup, right? So tomorrow, if we don't need the module federation anymore, it has been migrated to a full-fledged app, we can just change the Webpack config and things will just work fine. This is completely agnostic of all of that. That's basically controlled by Webpack. So, with developers with enough Webpack finesse, you can easily migrate this, no issues to anyone. This can be used by other. So right now, even if you have a different application which needs IPD access, given the right information to these, like the right props to this, they can actually use this.
Got it. Yeah. So there is that little similar sort of a loading code that needs to be put,
Yes.
like it's on the left, but it's free of the Angular parts. It's just the
Correct.
standard. How do I use a remote micro front end hosted somewhere else onto my app? Kind of.
Correct. That's absolute box standard module federation code and React lazy suspense code. It's going to work. A bit more, of course. They'll also have to the similar tech stack and figure out how to load the CSS and all of that stuff. But referencing this, it should be pretty straightforward. So the build of this is pretty much similar in a lot of senses to the IPD front end and also Carbon UI. Similar kind of Webpack setups overall, like in terms of the kind of files it can process and all of that stuff. It's just the module federation plugin that changes.
Okay. My last question was around debugging. So I was just curious. So as I understood, as far as the React only sides are concerned, debugging is normal React debugging for things that you're writing here, the drug chart and all. That's fine. On this side, are there any things that people have to do differently for debugging, or it's general Angular JS, the way you debug Angular code, you debug the same way?
So good question actually. So on that, before I get into debugging, one thing I totally forgot, to be honest, is that the CSS strategy, because it's SaaS, the CSS of core Bahmni is going to affect your React components also. So even though you can load these isolated, when you integrate it with Bahmni, there are decent chances that you have conflicts because Bahmni CSS tends to be a bit more overarching and vague, but those things would soon be ironed out. We have some conflict CSS and all that set up. That people are fixing the conflicts anyway. So in that sense, that would be one problem. And in terms of debugging, I believe that if I get a let's say this is a React debugger, right? It got hold of, so this is your React components debugger. So it got hold of this. So what this says here is that at the end of the day, this is not, this code is not really converting your React component to Angular, right? It's basically wrapping over React's DOM manipulation stuff, right? So at the end of the day, your React debugging tools will still be effective, right? So this is your component profiler in React, and it found those items. This is all React code that has been coming in from the Micro-frontend, right? So it found those items without issue. It might be like complaining a bit on some areas, but it has no issues, right? It found out, right? So that's a suspense boundary where it found the React component, right? So all of your tools which work with Angular and which work with React should work without any issue here. It's not really converting from one to the other.
Yeah, that's helpful. Thanks. Got it.
Other side notes, no special things have been done for authentication or because it's essentially just another front-end module. So if you're already authenticated and things are flowing correctly, it should not be a big deal as long as the API calls are all secure, all of that, like standard front-end JavaScript bundles, it's just like that. So nothing special has been done for that as of now. But of course, we'll probably check the security on this a bit. But overall, this should not be a super big concern. Yeah, that's about it, I believe.
My guess is if that thing is running in its own proxy, the host code, as you said, it needs to also run in the same domain, right? Otherwise, it will get those CORS errors, or you will need to allow for anyone to embed it.
Yeah, the standard web server serving and CORS connections and all of those have to be managed, right? So if we want another external React application to, let's say, get IPD in, all the standard stuff has to be managed, including CORS. Of course, that will also impact Gurpreet. We were talking about having a single container serving multiple micro-frontends. There, it might have a impact if we enable CORS for a lot of things without reason. But of course, all of those like standard web server settings and all can be managed just like any other thing.
Right.
Are
But in
you seeing
general,
any performance?
good.
There's a question in the chat. Are you
Yes,
seeing
yes,
any
yes.
performance overheads with this new architecture compared to existing system? Yes, there would be a slight performance overhead because of course we are uh, fetching a remote React component, and then of course that might at this point. So we've not solved any of the core uh, uh, problems that are already there. For example, like multiple config calls and all across different Bahmni applications. So those kind of things we've not solved, and uh, like the core React itself being rendered inside Angular does have performance implications. But the hope here is that this is a temporary measure till we move into a full React-based system, and the performance improvements can be found in other areas, right? Like Gurpreet, you were talking about getting the optimizing the calls and all of that stuff. But as a module federation strategy, it doesn't have too much of a performance impact because even that remote entry is being fetched at runtime. Of course, the performance impact of loading React itself, a tiny bit, it's going to be there. Since support for Node 14 ended, is there any way to use supported React version? Is it possible to serve minified flow from CDN instead of a separate container? So for number 2, yes, it is possible to serve the files from CDN. Of course, we'll have to build the pipelines and all of that stuff for that. And the Webpack configurations at the host side also has to be modified because host has the URLs for these files. We started off with container because that felt natural. But yeah, definitely possible with a CDN. Node 14 to improve. To be honest, I did not look too much into what node version. So I just picked up the node version, which is already existing within Bahmni. And there was some existing React usage. So I stuck with the React version and node version, which was already used because I did not want to break things while I was building something new. So once it's settled down, we can actually look very strongly at upgrading node and getting things running. Because honestly, I defaulted to 16 first and things broke left, right, and center for me. So I I covered down and went back to 14, to be honest, on that one. I hope that answers your question, Shiva.
Yeah, thanks, Anish.
A lot of the decisions here were taken purely from a safety point as well, because this was a large endeavor. So we wanted first cut to be as minimally invasive as possible. So we built on existing systems, we stuck to existing tech choices, and we stuck to existing versions as much as possible.
Anju, any thoughts, any questions? Anyone else? Questions, thoughts from Anish?
No, but I think one of the things is, I think we discussed about it, that we probably would not be running so many containers at all, right?
Yeah.
Module federation essentially wants a mechanism for assembling. So one part is obviously what Shiva talked about, right? Is there a way, for example, through our build pipelines, etc., we pre-generate, right, or pre-build, assemble stuff and then host it onto CDN is one, right? The other part about is this, that even if we, in our development environment, where most likely people are building things separately, independently, but let's say on our dev server, do we want to do things? Do we really want to run in multiple containers, independent containers? Why not just essentially use some web server, for example, on the same container itself, right? But different virtual directories like Apache would do. Then Webpack essentially just needs to fetch it from different different paths. That's it. Right? Or
Yeah,
is
sure. So complete. Yeah, sorry. So complete agree on that. This having a new container was just natural to me, but essentially once you have the build files, right, it's just a DevOps game. You get a good guy for DevOps and they can do all the magic and set it up as a single container serving multiple micro front ends or putting it in virtual directories. All of that is fair game. Webpack has zero opinions on that. So that is potentially the next step we can easily take.
because
Abhinay has, is there a way to have control over what are the compose to be exposed from an MF? Yes, so each micro front end, the module federation plugin has to tell what it's exposing. So I can quickly show you. So this is the IPD front end. And again, a lot of things here in the Webpack, but let me just find federation config. Yeah, so this is what that is, Abhinay. So here in the micro front end of IPD itself, we are saying that we are going to expose these two components, right? So we are not exposing every React component within a directory or something like that. We are specifically mentioning what are we exposing. And the host also has, the host will get all of these, right? So there is no more fine grained control over this. Like we'll expose this for some people and not for others, but essentially we can choose which top level components we are exposing. So that is very much possible.
Thanks.
Actually, you were saying something, I guess.
no.
Okay.
So has the IPD team started using this, or like besides you, Arjun, Surya, others, have they been like writing the code in this and it's all building in other
Yes.
people's machines and everything?
Yes. This is not written by me. This is written by Fani and Soumya. And the other modal Arjun is writing, I do not have the setup for that. But yeah, two different pairs have been working on this. Things have been spooked up. We had to fix some deployment issues, and we basically, from the last time I talked to you, Gurpreet and Anshu, we basically improved the design a bit more. But yeah, this is working, right? We've actually got some stories in done also, I believe. Right, Bindu?
Yes. It's up for the today's showcase plan with the client. Yes. There are two cards, micro front-end cards I've done where we can see both of it on the patient dashboard. One is on the drug chart. The other one is on the general dashboard as a model, a drug chart model. These two are something done using micro front-end.
And soon, I think in one or two iterations, we'll also be starting to use the local micro front-end setup. So if there are issues there, we'll iron out by that time.
Cool, thanks.
Cool. Stop sharing then.
Yeah, thank you, Anish. Excellent presentation. Great documentation also you're writing. Thanks a lot.